bacteria involved. And you see Gaia, the Gaia hypothesis. Lovelock coined the term, but Margulis was the one that gave Lovelock the understanding to know what Gaia was about. And so there's some quotes here. Copernicus, he talked about revolution, which means he said that the Earth goes around the sun. Pretty revolutionary. I don't know if you believe that. Darwin, we think of Darwin as evolution, but I think Margulis talks about evolution in a much more hopeful way. You know, I've got another slide here. Symbiosis is a much more hopeful interpretation of evolution than survival of the fittest. Wouldn't you agree? You know, and I said that. So, and making homes for microbes is critical for eco-machines and soil building. So yeah, so a lot of what we do is how do we get into smaller? And of course, Wayne Ingham talks about that a lot. She's the hero of nematodes. You know, she talks about nematodes a lot, about mycorrhizal fungi. And I'm going to go a little bit bigger today. And we're in New England, and I said I promised I'd get to soils of New England. Anybody know the first soil story in New England? In New England, you know, like European history. What's the first soil story? You know, what's the Squanto story?
Burying the fish.
Putting the fish in the barn.
Putting the fish, and they definitely didn't take the oils out before they put the fish down.
Yeah.
Right?
That's right.
So this is the kind of fish they saw. You know, the female cod, when they get to be about 8 years old or so, are much more productive in terms of eggs. We hardly ever see them anymore. Somebody in the Somerville meeting said that this was really a small kid. But I don't care how small he was, those are pretty big fish. And the key to cod coming back, I think, are this little fish. This is the Squanto fish. This is menhaden. Menhaden hardly ever get up here anymore. They're algae eaters. They go south in the winter. And they're fished out in Chesapeake Bay to the point of extinction almost. But there are people now at Pew and other places that are trying to bring these fish back to New England. There have to be a lot of them because, you know, they won't want to come north until they clean, you know, if they clean out all the algae down south, then they'll start coming north again. I believe anyway. And I have a thing that says how much can these guys filter in one day? Each animal 4 gallons a minute. If you had a school 1 square mile in size, it would be 178 billion gallons each day. If you had a school 100 square miles in size, which used to happen, that would clean out Chesapeake Bay in one day. The volume of Chesapeake Bay would be filtered through these fish. So this is what we want in the ocean, but you didn't come here to hear about the ocean. This is why I came to New England, John Todd. And actually, he embraced Lynn Margulis in terms of, I want to get all 5 kingdoms in my living machines. And here's the sewage plant. This is a plant that I turned the valve on to start this thing back in 1995. And that's sewage. Now those tanks go down 10 feet below the ground. And there was 250,000 gallons in that greenhouse. We treated about 80,000 gallons of sewage a day. We grew a lot of green stuff. So microbes are the beginning of your food web. But that's not what I'm going to talk about today. That's just what came off the wall.
We're not going to talk about what we're going to talk about.
Look at Lynn Margulis up there. But we have this theory that if we make soil... Oh, that's okay. If we make soil, we can end global warming. I drew this picture up in Seth's office. Seth's right here. Raise your hand, Seth. I drew this on a poster board with magic markers and taped the pictures on. And Seth says, I could put that into digital, which he did, and it's really great. And so that's my thesis. That's what I'm going to try to prove to you today. If you have doubts, I can stay till Seth's talk at 1 o'clock. But you'll notice back in the 1990s, when I first became aware of a guy named Alan Savory, I was living in Texas. We thought dung beetles is the way you buried a lot of carbon in the ground. You got a lot of animal poop. You had a big herd, and dung beetles would follow them around and bury that stuff. And then we found out about somebody named Christine Jones, And the idea that fungi take an awful lot of carbon from the perennial grasses and give it to the stuff below. This idea of glomalin came up. So this is about 5 years ago when I drew this picture. These were the big ideas. And I just put it up as a dare to the Boston people. There's so many scientists in Boston, and say, where am I wrong here? And I believe this a lot more now than I did then. You know, this was kind of a dare picture. So now here's your history question number 2. What is that a picture of? Carrier pigeons? Close. It's passenger pigeons. Who's that sitting there on the rock?
Audubon.
This is a guy named John James Audubon. You may have heard of him. This was exactly 200 years ago. And he saw these birds in Kentucky area, and he said, well, 3 days, there must have been 1 billion or more. Now imagine how much soil you can make. Imagine how much soil you can make out of 1 billion passenger pigeons, you know, visiting your neighborhood. This must have been a huge nutrient pump from the south to the north in the springtime, and from the north to the south in the fall. We don't have that pump anymore. It used to come to New England every so often. Yeah, but
I've seen a blackbird flock go by for 20 minutes.
there you go. How many were there?
I don't know.
That'd be fun to try to estimate how many
I
birds
was
go
trying to
by.
think about it, but
I want to refer to this later during my talk.
Yeah.
So
Good.
I have a quote from Audubon. He estimates 300 million per hour.
300 million per hour.
Oh.
And he was there for 3 days.
They figure there were several billion birds in a single flock.
Yeah.
That probably was almost 100 miles long.
And they would roost at night, and the trees would crash to the ground and so forth. So it's kind of like, how do we replace a nutrient pump like this? Or like the Menhaden. And here, this is what Audubon came up with. And you notice he's quite the detail. There's some of the, what's that, is that lobaria, or what's the lichen on the tree there? That I noticed. And then these are, imagine this bird is gone. So 200 years ago, we had this. And then on September 1st at 1 o'clock in the Cincinnati Zoo, the last passenger pigeon died. Her name was Martha. The biologist at Cincinnati Zoo had been looking for a mate for about a decade, but there weren't any that they could find. So imagine, this was exactly 100 years ago. This was the most important event of 1 century ago. World War I, you know, we're over it. We don't have this bird back. So I just take a second and think about that before we go on to more serious matters.
Just recall that this had a lot to do with the loss of chestnuts too. Hunting was certainly big,
Okay. Yeah, I'll bet. Yeah.
but the loss of chestnuts, which was their primary food.
Wow. Okay. I hadn't thought of that. I thought of oak trees and stuff, but
Chestnuts.
Okay. There's something else that we're missing in our future. And then, you know, here's I think about prairie dogs, and Seth will probably talk about prairie dogs a little bit. We estimated that there must have been 1 billion in Texas at one time. Imagine if you were a drop of water coming down in Texas and there's 1 billion prairie dogs. How are you going to be a flood? You know? And there's another animal here that's really, really important that we don't talk about enough. There were probably more pronghorn antelope in North America back then than there were buffalo. And now there's hardly any. But imagine if you want to bring back drylands. Pronghorn can go into areas that are much drier than buffalo can. So there's, and then notice this is also the United States Postal Service. Back when the stamps were 34 cents. This was a stamp. And everybody should have one of these, I think. So go out and get one. Okay, this is a little bit about me. I grew up in Pennsylvania, so I'm used to New England kind of woodsy places. But I went to school in Texas at Rice, and I spent time in the Army after that. I was a medic, and then I worked at the Bayer Labs And I was, I'm kind of sickened by what Bayer does now in terms of genetic engineering and things like that. I was in the polyurethane group, and I was responsible for the training of the technicians and chemists. And but then, while I was living in Texas, I got to meet Alan Savory just kind of by accident at lunch one time. He was at the same table, and I was really excited that Texas, you have the loss of land through desertification. But he was talking about you could reverse that. And I thought, wow. And he talked about cattle a lot, which I wasn't ready for at the time. But I'll present some evidence. And then I was fascinated by this guy named John Todd in New England, and I got to come up and do the living machine. I spent time at the Wolf Center, salmon and redwood restoration, fungi labs, and all these were kind of short-term things. And then Peter Donovan's coming here. Peter Donovan is the Soil Carbon Coalition guy. He's speaking here at 1 o'clock, I think, today. He's well worth. I've learned a tremendous amount from him.
3 o'clock.
At 3. Oh.
And it's in a different room.
Okay, Seth is at 1 o'clock and Peter's at 3 o'clock. And then everybody's meeting tonight at what time?
5 o'clock over by the Crabtree dorm if you want to come to the carbon farm and meet up and talk more about some of these things. Please do. Jim will be there. Peter will be there.
Jim,
Connor, in the previous workshop, will be there.
and you didn't announce these events yet,
I
right?
didn't get a chance to.
So you're not having that right now?
Okay.
Yeah, since we're on the subject of
Yeah, some things, yeah. I just want to let everybody know, Jim Jones was just referenced is coming to town, coming to Massachusetts on the 1st and 2nd of September. So about 3 weeks away. Two separate events. You could go to one or both of them a day long about carbon sequestration through farming practices. This is here. And Rich Shin, who's a local expert on the grass-fed beef, is going to be a day-long seminar on the 3rd of November.
All right.
And we also are getting Greg Judy, who's a real activist in this whole world, for our NOFA Mass Winter Conference in January. I don't have those flyers on me right now, sorry. And then Jerry Bernetti from Martins Creek, Pennsylvania, will be here in February. So there's a lot of events that are all based on trying to follow this course. We're trying to do as much education of ourselves with bringing in all these great experts from around the world and the country to help us bring us all up to speed and better speed. Thanks. What conference? In your conference, yes. I'm sorry, but
Well, you're a sponsor.
Well, I am, but you better talk about it.
We can do it, Jen. We can do it, Jen.
Yeah,
Yeah, we're having a conference too, so but you'll hear about that in Seth's meeting too. So okay, so now what we want to do is learn how to put carbon in the ground. And what we've been really good at is doing what? Oh, well, let's do this first. Being a medic, you start looking for these kind of things. How many people have ever seen somebody laying in the street bleeding? All right. And did you walk right by?
No. It was a car accident. We
It was
stopped.
a car accident?
Yeah.
Most of us would stop and do something.
Yeah.
And so I'm going to give you a test here. What about these people? These are nieces. Are they unconscious? Are they bleeding?
They're in danger.
What?
They're in danger.
You think they're in danger? You think they're paying attention?
Was that train still running?
Yeah, that's it. The train track is not well used.
So this is, you see cowboy boots, you see bare feet. I think that's pretty cool. And you see, yeah, so, and the reason I'm concerned about them is because this is where they live. This is the land just outside of where they live. And do you see anything in that?
Just rocks.
That's called caliche. And this is, you see this all over New Mexico and all over Arizona and whatever. This is when the calcium, this used to be under an ocean, right? And this has been broken up, and sometimes it's added onto because of evaporation, because when water lands in Texas now, it doesn't sink in. It tends to just evaporate, or it runs off. And they're trying to grow wheat here. Now, this is not in West Texas. This is in Dallas. This is north of Dallas. This is 40 inches of rain a year. Yeah, and this is why I'm concerned about these guys. I don't know where they're going to get their food from, you see. So this is what I'm trying to figure out how to reverse. And so if you're going to be a land medic, what do you look for? In fact, we got some caliche around here somewhere. Here. Why don't you pass some of Texas back around and see, how do you think you could get something to get their roots into that? So that's so now if you're a land medic, if you care about the land, how many people have ever seen bare ground? That's not normal. You know? How many people have seen any mud in the streams? You know, that ought to be a yell emergency. You stop your car on the bridge and say, whoa, we got an emergency here. Our wealth is being washed away. Probably you don't. I haven't seen a lot of that going on.
Your car was never moved.
So that's the dilemma we're in. And here's an example. Anybody know where this is?
Great Britain.
Great Britain. Here's the North Sea. You see a lot of stuff going down the Thames. And over here is the Wales. You see Wales to the north. And a lot of wealth of England is going out into the ocean. So that's one way to lose your carbon, is to the ocean. Here's another way. Well, this looks like Tonka toys, right? And can you see the driver in that machine there? You know, I've got let me get technologically. Where's the driver's in there somewhere? And this huge piece of equipment here is Bucyrus Erie. This was made like in my home county, Erie, Pennsylvania. You know, not too far from where I grew up. You know, a lot of these parts, I'm sure they assembled it on site. This is in Maryland. And if you have any doubts about how big these things are.
Maryland.
Yeah. This is the skinny part of Maryland that's between Virginia and Pennsylvania. And this is all the coal that came down from the Pennsylvanian era. That's why they call it the Pennsylvania era. Pennsylvania had all the coal. It had the best coal, too. The anthracite. But look at how much we're taking out. You know, tons and tons and tons. And where's all that carbon going that they're pulling out of there? Straight in the air. You know? And I was there. I was lucky to ever get these pictures, but I was there because we're thinking about, well, how do we clean up after something like this? And that'll be all our jobs pretty soon, right? I was born in 1949, so I would say it was maybe 310 when I was born, the carbon in the atmosphere. Feeling started measuring it in 1958. Seth will tell you more about that. You know, but it touched over 400 last year for the first time. It doesn't look like it's going to bounce off 400 and go back down anytime soon. And our contention, Adam's contention, the biodiversity group that we put together is that the only way we're going to get this number to go down, and it has to soon, is if we figure out how to make soil and biodiversity. 389, when I did this chart, is the number. And that was the year Jim Hansen finally came out and said 350 is the maximum number that might be safe. And McKibben jumped on that number. Hansen would much rather see 325 or 300, but 350 was considered the absolute limit. So that was important because we were already above that. We were already in a pathological state. And IPCC at the time was saying if we had a 50% reduction by 2050, we would start gradually declining and maybe peak somewhere around 450. I don't think anybody's thinking we're on our road to a 50% reduction. And then here's what the coal industry thinks. It says, well, we'll be fine at 1,000 because trees will grow faster. You know. Last time it was 1,000. Well, let's see. Last time it was 450. At 425, 2 million years ago, the sea level was 80 feet higher than it is now. And in Boston, that's pretty important because that's the top of the Green Monster in Fenway Park. The top of the Green Monster, which is 37 feet high. So it's also, if you know Somerville, it's the top of the Somerville Theater. Tufts would be an island. Tufts University would be an island in our neighborhood. So, and you know, so that's the last time it went to 1,000 was 50 million years ago in the Paleocene, and they had an extinction episode that looked a little bit like, well, Peter Ward talked about it. 2007, the same year, Peter Ward comes out with this book, and look at his words here. This is in his introduction. He's over in Nevada. He said, "This book is my scream. For here in Nevada, we sat on the remains of a greenhouse extinction from 50 million years ago. And it wasn't pretty, this graveyard." And then he says, "It's happening again. Most of us think so, but there's so few of us that look at the deep past and compare it with the present." You know, the paleontologists, there aren't many, and people don't listen to them with ears that think about right now. Thus this book, words tumbling out, powered by rage and sorrow, but mostly fear, not for us, but for our children and theirs.
But
This was under a green sky.
that's an underestimation because now it's for us too. Everything's happening so fast.
Well, remember Muller Canyon? He wrote this in Muller Canyon, okay, which is in Nevada. Okay, this is what that extinction looked like. Elaine Ingham yesterday talked a lot about how if your soil chemistry changes to sulfur chemistry, it starts smelling like rotten eggs. Imagine that on a global scale. Imagine an ocean this is your ocean supposed to have oxygen in it all the way down to the bottom. We're really lucky that we've got a lot of ice in the North Atlantic, so it drops really fast. But look what happens if we run out of, that doesn't turn over like it used to. And you see the hydrogen sulfide coming right out of the ocean. And if there's enough of it, then it affects the land too. The acidity of the land and so forth. This was 50 million years ago. Of course, every extinction, new things happened afterwards, And Peter Ward thinks that, after this extinction, mammals will have a real rough time because we're not really good at breathing air that doesn't have much oxygen. But birds are. Birds are much better adapted to that, so it might be an age of birds. Is that what you want to see? That's not what I want to see. So, and you notice that extinction episodes are happening at lower and lower CO2 amounts. Jim Lawrie thinks that that's because the sun is getting warmer over time, and so we can't have as much CO2 in the atmosphere. So we're kind of going down on this curve, and then we're kind of looking like we're trying to intercept that curve on the way up. So that's my case for extinction. Let's go to what's happening right now. These are Alan Savory slides, Africa. This is the cryptobiotic soils that came up yesterday, and they said, well, Elaine Ingham called this a desert. And I imagine this was taken in Zimbabwe or maybe in New Mexico. But you can see the algae crust. And is that what you want for New Mexico? You see? Deserts aren't deserts because, they're inevitably deserts. They could be grasslands too, almost everywhere. Here's the graying. Alan was trying to show. This vegetation isn't very good for animals. Animals can't get much out of this. So you want to graze this stuff before it turns gray. Here's more brown stuff, but because there's no animals to eat it, they're setting fire to it. It's still very, very common. And so let me try something here. We'll bring in Bruce Ward from another Ward. Bring him in from Australia. See if I can do this magic trick. Come on, iPad.
What am I talking about when I'm saying healing the land? Well, what I'm talking about is literally the soil surface, the very top, the interface between the earth and the air. At that soil surface, we need to keep that covered in litter, organic matter, and we're looking to probably have an inch, 25 millimetres of cover over the soil. And that litter is like your skin, my skin. If we were to lose our skin, it would hurt. It would hurt like hell. If you create bare soil, exposed soil, then that's exactly the same thing for the land. It's hurting like hell. There's no protection for the microorganisms, there's no protection for the water. The soil starts to get capped or hard and it becomes like an asphalt surface, and water runs off instead of going into the soil. Productivity goes down, and the problems gradually over time just get worse and worse and worse. Ecosystem function is degrading rather than improving.
So, how many people said emergency? Hey, Carl. Carl's here. So, what do you see happening there? This is right in the middle of Texas. This is maybe, I don't know, 80 miles west of Austin. There's a lot of mesquite growing. Most people in Texas blame the dryness on the mesquite because they say it takes all the water. So they've gotten bulldozers and knocked a lot of it down. Mesquite's really good wood for a lot of things, but maybe they harvested some of it for firewood or something.
Beans.
And it's good for beans too. It makes a real good food. So now, look at this. I thought this was really cute. You can call Tyson Gilbert, and he can do your land clearing. And you look at the ground, and they've actually burned this stuff that they've made. There's a lot of caliche in there. And where's the caliche? Is that getting around? And look at that. Now what they want to do there is they want to seed this, and then raise grass, and then run sheep on it. Now think how expensive that is. And where's the water going to come from? If it rains, is anything going to go down into the ground? Or is it going to run off? Or are we going to have flash flooding? But this is pretty typical of Texas right now. Here's something else. What does this land look like? How do you like that? Where do you think that is? Any guesses where that is? It's Texas. It's the Red River. In November, not in the dead of summer, it's in November. And you see, well, there's some water there.
Red River Valley.
Yeah. And now, actually, I've got some of the Red River. I actually went out and dug some of it up. The date's not right, but here's some Red River. All the minerals of Texas are in that. It's valuable to do something with that. So, I'd never seen it so dry. This is what, you know what this crop is? This is cotton. Upstream from where that picture was taken. You see cotton and the soil's red. There's no organic matter in the soil that I can see. Maybe a little bit. But, and these things are about the size of school buses. They're huge. There's cotton bales. So we don't have any water that stays on the ground in Texas very long. It either evaporates or runs off. And so here's this is the first part of the talk. I thought if I could get through this in half an hour, then you can take a deep breath. Everybody take a deep breath. And this is Dina Metzger. And I absolutely say this to myself often. There are those who are trying to set fire to our world. We are in danger. There is time only to work slowly. It's not time to panic. It's not time to do any of that stuff. And there's no time not to love. And if you care about those passenger pigeons, which I cried when I heard about the passenger pigeon at 12 years old, Well, there's going to be a lot of crime going on, but that means you're human, and I think that's amazing. So Dina Metzger. So that's the end of the first part. We are in danger. So what do we do about that? Any ideas? So, well, I like to go to this map. I do this with the college kids a lot. This is a map of the rainfall of the United States. And I ask something like, where do you think that deserts are inevitable of all the places in the United States? Do you see any place there that deserts are inevitable? Nevada. Nevada! I don't know why they always say that first. Whereabouts in Nevada? Take the whole thing? What about right there? Is that pretty good? Okay, I'll show you a picture of that place. This was 1989. This is a gold mine tailings pile that has had cyanide running through it to get the last of the gold. It's maybe 200 feet tall. Okay? And the mining company was supposed to grow something on it. They got a little bit of sagebrush that survived, but because they had to flush a lot of water through there to get rid of the cyanide, I mean, it was sterile stuff. And the water, evaporated off, and there was a lot of salt in there. There were crusts of salt on the top and things like that. This is about the worst land you can imagine. And the mining company was paying penalties for this. And one day, this couple showed up. And this is Jerry Tipton. Tony and Jerry Tipton showed up and says, "We want to do something on this. Let us show you how." And they said, "Okay." They fenced off 10 acres. They got all their friends to bring their cattle. There were about 600 cattle. And they brought in, everybody got their pickup truck and brought about 30 tons of hay. And she carried 100 bales of hay up this hill that day. The cattle followed her. And a lot of it they ate, but a lot of it they pounded into the ground. They put some carbon into this stuff, which isn't really, is this soil? It's dirt. For those that went yesterday, we heard that a lot. And when you make soil out of this stuff, this is the biggest challenge. This is the driest part of America. 6 inches a year. Okay? And this was a few months later. This is the biggest stand of grass they'd seen within 100 miles. They actually measured, I forget the numbers, how much they got, but it's up to, knee-high, thigh-high, and 6 months of growth, 1 inch of rain. What was the key? 60 tons of dung and urine went on that land, on that 10 acres. 6 tons per acre, and then they left. They left after 4 days. They were trying to get the nutrition from the animals. And this place was in good shape for about 2 years, and then it started to degrade again. It was a lot of work to bring those animals out there, and then it started to degrade again. So they figure about 2 years, they were ready for another shot of animal impact. In Nevada, that used to be antelope. They used to have grasslands in Nevada yay high for parts of the year because they had millions and millions of antelope. So Dan Daggett talked about this. Dan Daggett was a Sierra Club environmentalist that used to fight ranchers all the time until he went out to see what they were doing. And there were some ranchers that had grazing plans. And he writes these guys up. And then here's Tony and Jerry Tipton when they lived in the school bus in Mina, Nevada. Now, if you remember Peter Ward was in a place called Muller Canyon. Muller Canyon is right here. And he decided that we were headed for another extinction episode. And that Greyhound bus that the Tiptons lived in was like 10 miles away from that. It's like all in the same place. It was just kind of odd. I was reading about both of these stories the same week, and everything was pointing to Nevada. Now what this did for me was it proved to me that you can not only restore Nevada if you want to. I mean, if you want to leave it as cryptobiotic soils, go for it. But you can restore the Karoo, which Seth will talk about a lot, and you can restore Australia, which Bruce Ward, he's an Australian. So that's kind of our summary. Where have we come here? Now that took 6 months. And if they'd had animals come in every 2 years after that, that'd still be going on. You know. Now what is this? This is beaver activity in Nevada. And they don't have much to work with. But they're working on it anyway. Yeah.
That last slide, was that growth was just what 1 inch of rain in 6 months?
Well, there was 1 inch of rain, but now think about it. The rain actually went into the ground to some extent because the animals had broken that up. But it was mostly the animal impact. It was the poop and it was the dung. That the microbial communities got started again. And so they got pretty good growth that year.
So the drought that followed didn't affect it?
Well, for about 2 years it was in pretty good shape. And then they saw it starting to degrade again. And you think that the West is now, a lot of it is desert. A lot of West Texas is desert. There's hardly any animals on the land at all. They're all in feedlots. And, they're feeding them hay. It's just ridiculous. But it took a long time for that to happen. Nobody remembers anymore what that used to look like. I hear in the movie Red River, they talked about John Wayne taking animals out to the Pecos. And I used to laugh at that. But the Pecos used to have grass this high. Buffalo used to go out to the Pecos. So that's, and these are all my opinions, right? I could be wrong, but I'll just give you some more evidence here as we go. So beaver activity. Now beaver are coming, I'll talk about them a little bit more later. I think that the idea of trying to get animals to every part of the West is a great idea, and we turn it into the Peace Corps, and we have the Pentagon do that instead of do what they do. I forget sometimes. But what if we had everybody in America had to go out and spend 2 years out on the prairie, restoring the land and pushing animals, and then what's that? All right, we already got a volunteer. So imagine that would be a chance. I mean, it's the Defense Department, right? We're defending our future. So here's another picture. This picture was taken near where my nieces. You saw my nieces on the railroad tracks there, and they put this plaque up. It said 40 to 60 million bison roam the continent in vast herds. It says, and then at the bottom of this plaque it says, at a time of great tribulation, a time of great tribulation will overtake you, and you will lose the buffalo, the land, everything. You notice they say buffalo before the land. You'll lose everything down to your very lives. When all hope seems lost, I will return and bring the buffalo back with me. The legend of the white buffalo woman. Now this is on the Creston Trail, which was the most important trail going up to Kansas in Texas, north of Dallas, near where my nieces live. And this is the monument that's there, and this is on the main drag now. Right across from Wendy's. One of my nieces, the little one, is named Wendy, so she likes that place. And I just thought, this was where the soil used to be yay high, and now it's caliche that you have in your hand. So that's why I get concerned about, here's the map of the buffalo at one time. And it's also where 550 buffalo here, and then these numbers here, they're hard to read, but there were about 200 left in Yellowstone when the cavalry protected them. Sheridan and the cavalry protected Yellowstone. It was the first world's national park. And there were we know of maybe 100 other buffalo in the world in 1889 or so. Now look at where they went. West Texas, Coahuila, Chihuahua, Sonora, Baja. Now how could they go down there if there wasn't grass? Chihuahua must have been full of grass. Sonora is hard for me to imagine, but you know, that many buffalo ever got out there. But and then notice where else they went. They went to Lake Champlain, Buffalo, New York, Buffalo Bayou, Houston. You know, they were a lot of places. So that ought to be part of your project when you join the.
Well, I'm on Lake Champlain right now.
Oh well, there you go. Maybe we'll have to go farther. So that's my hope is that we can end global warming and make soil. But now you have to know how. And it turns out humans don't make soil very well, but there's a lot of species that want to volunteer. And we talked a little bit about grazing critters, and we have to know a lot about perennial grasses, things that put roots down very, very far. Elaine Ingham's been talking about that a lot. Earthworms and dung beetles I'll talk about some more. Prairie dogs. We've talked about fungi yesterday a lot. You want to become mycorrhizal fungi experts. Because how much of the photosynthetic product that plants take out of the air do they give to the fungi to feed the below ground stuff?
30%.
How much?
30%.
30%? Any other guesses? I don't know, but it's probably more than 50.
Depends on how healthy the plant is.
Yeah. Yeah, so it's a big number. And if we focus on what's below the ground, there's endless possibilities. Dung beetles, 3 feet down. Let's go look at this some more. Here's the map of the pronghorn. And you see Nevada. So that's, how many pronghorn were there? Well, the estimates go up to 100 million. Mostly in brittle environments. Brittle environments are places where it doesn't rain all year round. And you have a dry season, so you have to store your water in the ground somehow. And we're finding that prairie dogs, beaver are incredibly good at doing that. It may be when you lose your beaver, not just your grazing animals, but your beaver, that's when the desert comes. And 400 million prairie dogs in one Texas prairie dog town. That was maybe a quarter of the size of Texas. So what do you need? You need buffalo. Now this is a picture that was taken in South Dakota. And you see some poop on the side on there. So there are some animals hanging around by the river. I don't know if that's is that herd density enough, do you think? What about that? This is an area of Patagonia. Pablo Borelli, a bunch of folks, both in Chile and Argentina. They're working with Patagonia, the clothing manufacturers, to create a wool but they think, well, all right, you want to hit that area hard, but then you might have to monitor the land before you bring them back. This is where Seth's going. 400% increase with plain grazing. Is that comment on that slide, Seth?
At 1 o'clock.
At 1 o'clock.
We're increasing what, soil carbon?
What's that?
Grass production. Grass production?
Well, the way we thought about it in Texas, if you had 400% increase in your herd size, you'd have 400% increase in your grass. That those two went together. So,
But that's
The
referring
grass
to
production outpaces the herd size, so it's more than that.
yeah, okay.
That refers to the herd size.
That refers to herd size.
So they're carrying.
Yeah. The problem in a lot of these places, there's a little farm called Signal Rock Farm near Charlton, Massachusetts, not far from here. And they've got sheep. And they were running 110 sheep on 1/7 of an acre. But they moved them every day. So think about that. In a week, they were using 1 acre. 110 sheep. That's about as many as they wanted to have. In 5 weeks, they could come back to because in Massachusetts, in 5 weeks, the land's recovered. So they needed about 5 acres to have 100 sheep. They had 200 acres. And they said, everything's turning to brush, we can't keep up with it. A lot of places that get into this planned grazing and they give the land time to recover have more grass than they can handle. So it's just a way of thinking about it. If you start thinking and focusing on the perennial grasses and how do I maximize that, you get a much different answer than if you just focus on the animals. So that's the only point I'm making here. But, every piece of land is different. So, and Seth will talk about springbok. that's a huge story. And oh, I wanted to show a movie. I'm going slowly because I'm not an expert at doing this yet. What is that one? Here we go. This is about 6 minutes. Can everybody see?
What would happen in the winter for beef farming or dairy farming? It's just part and parcel of what we do in this country because of our climate.
This is in England.
If we were to leave them out on the land, it's actually bad for the pastures because they carve up the grass and it hasn't got enough time to recover for the next spring. And obviously with the cattle in the barn, then they can't get to their grass. So we then have to bring their grass to them in the form of this hay. And the hay harvest by far is our biggest single use of machinery and fuel on this farm.
This is why I was fascinated to hear about a farm up in Shropshire run by Charlotte Collins and her brother Ben. Ford Hall Farm is much the same size as our farm, and like us, they raise cattle and sheep. But at Ford Hall, the cattle stay out on the pasture all winter with little need for additional feed. I found it hard to believe that as a result, the only machinery they have is a quad bike. The secret to this is underfoot, the grass. Even though we have hundreds of species of wild grass in this country, most farmers only use 4, which they buy in a bag from a seed merchant. But not at Ford Hall.
And we've probably got almost 20 different species of grass here. Some are hardier than others, some will grow quicker than others, and some have roots which go deeper down in the soil and bring minerals up, and some have got much shallower roots which help them to take the soil across the surface. But if you come down and have a look at the grasses here, then you can see straight away that you've got a great big tight structure there at the bottom.
Scottish twig.
Exactly,
Yeah.
and even when you get to the soil, it's so matted up with roots.
Right.
It takes an awful lot of force and effort to break through it. So it doesn't get trodden up to a muddy mess straight away. And then, of course, the cows and the sheep get the benefit of it, and you get the benefit because you have to buy so much feeding. We know year on year it will work, there will be feed, we can produce beef, we can produce lamb, and we can sell it and we can make a living. And whatever happens to oil prices or anything else, we know we can keep going on that system.
But these amazing grasses didn't happen by chance. Charlotte and Ben's late father, Arthur Hollins, was a bit of a local legend and a farming visionary.
You know, Dad started his way of farming just after the war, but he spent his whole lifetime developing the system. And it was only just before he died in 2005 that he actually said, I'm happy with this. You know, I think I've got the grasses right, I'm happy with the pastures.
The soils on our farm are completely different to the ones here at Fordhall. So the grasses Arthur encouraged may not suit our fields back in Devon. But that's not to say we couldn't try something similar with other types of grass. Knowing which species to encourage may be just a case of careful observation. And that's exactly what old Arthur had to do, because the pastures here weren't always so rich.
You know, Dad was always a great observer, and he came through the woodland and he saw how much was growing here, you know, especially during the summer months, and he wasn't touching it. But more importantly, he wasn't paying for any of it to grow, he was just doing it. And he saw straight away in the top few inches of leaf litter on the soil there was life, whether it be spiders or woodlice or centipedes. And then you go down a little bit further and you start to see worms. But he couldn't see any of that in his soil planting and cultivating year on year. There was no sign of any life. It was dead. It was dead. And he got to then learn about all the millions of different bacteria and fungi that are also in the soil that keep it fertile, that cycle the nutrients, that hold those nutrients in their bodies and release them to the plants. And they weren't in his soil.
I mean, if you just look down, I mean, this is classic woodland soil.
Yeah.
How rich this is.
Exactly.
And it's gorgeous, gorgeous, rich topsoil.
I mean, even there, in that soil, you've got bits of twigs, the bits of leaf that are slowly being broken down to create soil. And the worms, everything else do that job for you. They eat it, process it through the bodies, and you end up with worm poo, you know, which is soil, which feeds the plants. And without that life, you've got nothing to feed the plants to keep that system going.
Taking the lessons he learnt from the woodland, Arthur realised that to rejuvenate his fields, he would have to go against one of the most fundamental principles of agriculture.
I mean, the biggest thing that Dad found was damaging the soil was actually exposing it to sunlight. It was that overturning through ploughing. And Dad always said it would be like humans ripping off their skin. You know, it's not nice.
No.
And, you know, and you don't survive.
No.
So why do it to the soil, and why kill all those organisms in the soil that at the end of the day are your best friends?
Charlotte, are you telling us not to plough?
Yes.
We've been ploughing for 10,000 years. It's what farmers do.
Not ploughing is a pretty radical idea for any farmer. But looking at some old footage from our farm, the damage it causes is now pretty obvious. This is one of our fields back in the 80s. The life in the soil is a feast for the birds. After 20 years of the same treatment, no birds, the soil is dead. Turning the soil has been part of agriculture for millennia. But I guess with muscle power alone, the damage was slow to show.
I'm going to stop that right there, but she was 26 years old when that was done. They were born when their dad was in his 60s, and they've become quite amazing. To save that land near Liverpool took about 800 people in the community coming together. It became a community farm, and so that's a neat story, I thought. And we'll go back. Now, what I liked about that was she says, well, what happens if you plow? It's like ripping off your skin. It's not nice and you don't survive. Of course, Bruce Ward said it hurts like hell. You know, they have different ways of saying it, but and it's the Elaine Ingham story too, you know.
Native Americans said it too.
Well, there you go. Soil's upside down. Yeah. So here's this picture. Carl has been spreading this picture around a lot. I didn't actually see this guy when I first looked at it. He's sitting on the soil of New Mexico 100 years ago. The soil was up here. What is that, loss of 5 feet of soil? But what really excited me about this is big blue stem. This is the best grass in the world, and people out in New Mexico now think that's an invasive species. But it could be everywhere in New Mexico, and it's incredible for grazing grass. And look how well it held the soil here. It's a remnant. There's been no animals to bring nutrients to this stuff. And so I did some calculations. 4 feet deep, we probably lost 5,000 tons of soil per acre. If it's 4% organic carbon, which it probably was, well, that's 200 tons of carbon lost per acre. That means if a third of, well, let's see, New Mexico is about 60 million acres. If a third of New Mexico was like this, that's 4 gigatons of carbon that's disappeared. That's enough to, if they put it back, it'd be 2 parts per million right there. Just a third of New Mexico. But look how, you know, this is a museum. But what if you could bring that back? Now, the soil blew away to the point where we're down to caliche. So we have to build something on top of it. But yeah, that's a challenge. How do we do that?
Would caliche be considered a heartland?
Definitely. You know, but that's what, you know. But you can see how it happened. Now, there was, you know, it's interesting because in New Mexico we have the Spanish tradition, which was grazing, crashing into the English tradition, which was farming. And the farmers wanted to plow, and the people who came up from Mexico wanted to graze, and so they're banging. Now, who won? I mean, who had more votes? And those areas were losing grass, and there was a lot of erosion and stuff like that because there were far fewer animals when they started continuously grazing and putting up barbed wire and whatever. But when the plowing started, that's when it got impossible. And in World War I, they made a lot of money selling grain to the army. But then after the war was over, the prices went down. There wasn't the demand for grain. But the farmers out there had so much land that they said, well, let's plow 3 times as much. We can make as much money, we just plow 3 times as much. And the soil blew away, literally, overnight. And Dust Bowl, you know part of that story. Now this picture, I mean, there's lots of pictures like this, and every piece of ground is different. But it says, trees put most of their biomass on the top, and there's not as much organic matter down here. And deserts don't have much organic matter in the soil. The brown stuff being the humus-like stuff. But look at how they show grasslands here. And the potential, we think, is in areas that are desert now, if they were grasslands, they could store a lot of carbon. Now this may not be New England, and I apologize for those who came to hear about New England, because we haven't gotten there yet. But just to think, if you think about climate, we're thinking about where can we put all this carbon, and we can put it a lot of places. What are these guys?
Dung beetles?
Yeah, these are dung beetles. And they're having a hard time because there's not a lot of dung here. I have this saying, I say, all over the world, dung beetles are starving. And in Cambridge one day, the lady got up and said, well, what do they eat? I says, okay, now we're getting somewhere. We're learning. Dung beetles take their babies down 2 or 3 feet down. They roll up everything in a little ball. When they do that, the moisture in the dung pile disappears, and the fly larvae never grow up. So you don't have flies on your animals. So dung beetles are great. But you kill them with antibiotics, different things that the cows are eating. You kill them with insecticides. Dung beetles are having a hard time. And they like the smell of that dung, so if you have a big herd, that's always better. And this is Joe Maddox. This is out near the Pecos River. Remember how dry the Pecos River is supposed to be? He got a pretty good rain that year. He's been running cattle out there after about 5 years. He had 4 times the recommended herd densities. He moves them every week. And so they only see the same land after 6 months of rest. And this is Mexican hat mostly. Wildflowers showing up that spring. And Joe's in his 60s when that picture was taken. And he tells me a story about when he first saw dung beetles on the land. And he just got off his horse. This great big guy gets off his horse and he's down in the dirt, and he's just in tears. He's crying when he's telling me the story. Because he's heard about them, but he hadn't seen them in years. And he knows that that's good for his land. So that's the kind of love that I'm talking about. So a couple of professors, husband and wife team, Dick Richardson and Patricia Richardson, show up and they count dung beetles for a summer. And they're saying they say at the end of the summer, they say they can bury a ton of wet manure per acre per day out there. This was in Oklahoma that they did this particular test. But
how many, is that like one beetle, or is that like
no, there's a lot of beetles. She said she counted 106 dung beetles exiting in 6 minutes. Well, I asked her, I said, well, one ton of wet manure per acre per day, that's a pretty precise number, right? How did you get that number? And she says, give me a break, Jim, give me a break. We only had a summer. It might be much more than that. But we feel good about saying that number. They said they'd sit out there at night and they could just hear the activity. Do you ever hear termites at night? Well, they were hearing dung beetles at night. It's much more pleasant. Yes, tell them your story.
So when I was in Africa, we saw several pounds of elephant dung disappear within half an hour.
How many dung beetles?
The whole pile literally the pile of dung was pulsing.
How big?
Because there were so many dung beetles in it, and within a half hour it was gone.
Yeah, speak up.
Yeah, I'm relatively new at raising some cattle. I have a small herd, and I'm looking to find a dung beetle that does well and can overwinter in New England, but there's not a lot.
I think Abe Collins is coming to speak here tomorrow.
Okay.
And he's had him up in Vermont, and he may have some ideas about that. Because I'm curious about that too. I want to come tomorrow and hear what Abe has to say. So Jane.
I was just going to ask the same question.
Oh, okay. Yeah, we got to learn more about dung beetles here.
I mean, we could introduce dung beetles like earthworms, like all the grasses, and then we have Siberian system really.
Yeah.
But none of that stuff is really native here.
Well,
there might be some species.
Yeah.
That might form a similar role.
What happened on this farm? This was actually on Walt Davis's farm, and he brought in some Australian. Well, no, actually, that's not how it happened. He brought in some Australians later. But the first thing that happened to Walt was he couldn't afford chemicals anymore, and he quit using them. He'd been through everything. He'd been a rancher forever. And then a year later, he's asking himself, something was wrong on the land. He goes out on the land, doesn't look right. And he says, wait a minute, where are all the cow pads? They were just not there. So he calls these professors up to look at this whole thing. And like 10 years later, he had 6 species. He brought some Australians in, but there are other species. Yeah, 6 species of dung beetles.
Well, I don't know. I love Australia. Pretty strange animal.
So I think that probably if a lot of people started doing this, we'd see more species coming back. The thing about invasive species that I have, and John Todd said this all the time, we live in a world that's not like it used to be. And we're in danger. And we have to welcome all the immigrants we can if it's helping the land get healthier. And I'll have some more to say about that too. But don't get too uptight about whether it's an invasive species or not. Does it help the land get healthier? Does it help the process?
And of course, if you want to talk about invasive species, the best place to find one is in the mirror.
Or you could say sheep. This is the Maddox sheep out near the Pecos. This is in January, so it's pretty brown right now. There's a lot of mesquite. When they stopped fighting mesquite, they saved about $250,000 a year, and they started making money. They quadrupled their herd size. They got hunters to come out and hunt for mule deer. Now, if you've got hunters and you've got your animals on a 25th of your land, you don't put them where the sheep are, okay? You put them over on the other side. Now, if you're a mule deer, what do? Where do you hang out?
With the sheep.
With the sheep. They never lost much wildlife. They had more wildlife because they had more water than they'd had. I woke up on the ranch, 400 turkeys. And I says, wow, I couldn't sleep this morning because the turkeys were going crazy. And he said, that's more turkeys than we had in the county 10 years ago. The wildlife will show up if you can get water to go down into the land. But they do have grass showing up here now. There's much bare ground. This is a ranch that they'd only been working for about 7 years. And they run their cattle with the sheep. Sometimes they're embarrassed, But, this is cane bluestem, and this is what's his name? His last name's Beck. Is it Walter Beck? He came all the way out there and he said he hadn't seen cane bluestem within 100 miles of the place. As he went west of Austin, he didn't expect to see it. And here it's showing up. And really good grass for your animals. The seed is in the ground, usually. You don't have to buy seed. When Elaine Ingham tells you, don't buy those things they tell you to buy, don't buy those supplements, don't buy any of that stuff, you don't have to buy the seed either, probably. And then you saw a lot of this yesterday.
No.
Here's your turf grass. Here, see the seeds, see the roots there? This is what we try to grow in Boston. And we can make it real green if we add a lot of stuff. But I'd rather have something like this. This is bluestem. So, Carbon Ranch in Colorado. Kibera Coalition is a great organization. And if you want to learn more about that, come to Seth's talk, because we'll tell you more about it. He knows a lot about those Kibera people. Now, how would you like to see this? If you're raising cattle, how would you like to see this? Now, can you see the bare ground? You scream emergency? This is taken, the picture's taken standing up. And this is Greg Judy and his wife, who's, I think her name's Jen. And this guy has written down in 2 simple books everything he's done. Maybe I got a picture. Comeback Farms, Rejuvenating Soils, Pastures, Profits, with Livestock, Grazing Management. Let's go, we'll let him talk for a minute. Let's see. Oh, there it is.
Folks, this is what all your pastures need to look like.
What's he doing?
Y'all know what you're looking at right there? It's solid earthworm casting. Solid. Look at the little mounds. Folks, this is all new soil being formed every day on our farm. Look at that. That's all new soil. It wasn't there 120 days ago. Where did it come from? It came from the litter. There is no litter bank left here. You know why? It's all been turned into soil. Folks, this is black gold.
So, I think I read this book about 3 times because it was so information rich. In the year 2000, he'd lost his first marriage. He didn't have any land, he didn't have any animals, he didn't have any money. And he tells you how he went through that. And he found out that really dense herds and leasing the land and, not spending a lot of money, but, and he found a lot of people out in Missouri where he lives. There's some earthworm castings. Out where he lives, people that own the land don't know a thing about how to care for it. And he's got a lot of places where they would let him lease the land for nothing because the land was getting so much healthier. He'd hold so much more water. And so he's trying to get to 25 earthworms per square foot. He figures that'd be 100 tons of earthworm castings per acre. That's just his calculation. That's what he measures. He goes down and counts earthworm holes. He'll cut out the grass and so forth. And that's kind of a simple thing to measure. And he considers, and he'll let the grass grow this high. They come in and tear it down. They might eat a third of it or so, trample the rest down. And I don't know, Adam and I did some calculations and figured he was getting about 3 tons of carbon going into the soil per year, per acre. You see? Well, that's 12 tons of water that the land will hold per acre. How would you like to have that stay on your land instead of going downstream? And are calculations absolutely right to the nth decimal place? No. But that's just my guess. It is. So what if we had 10 billion acres that are desert now and we wanted to put, or desert or poor degraded land, and we wanted to put 1 pound of carbon add per acre foot? That's not 3 pounds. But, let's look at this on a big scale. That's 20 tons of carbon per acre. Okay? 1 pound per square foot. So if you could put 3 tons down per acre, it'd take you maybe 6 or 7 years, maybe. And let's say we wanted to go down 100 parts per million, 390 to 290. That's 100 parts per million. That's 200 gigatons, 200 billion tons. Well, if we had 10 billion acres, 20 tons per acre, that's 200 gigatons. How many degraded land acres are there out there? Well, there's at least 10 billion brittle lands that are like that. And there's another 5 billion lands that are more like New England, which are, like Iowa is lost a lot of its carbon, but they're not a brittle landscape. There's probably 15 billion acres to work with. So we could solve the climate thing. That's our thesis if we made soil. And maybe if we quit taking all that coal out of the ground, that would help too. Here's one of my favorite species. Dandelions, feed the rabbits. You could use it for your own salad too. They bring calcium. They got a deep taproot. They bring up calcium. usually if you have dandelions around for a while, they pretty much get wiped out by the clover because the clover likes the calcium. And now, what do you have if you have clover? You got nitrogen. So now you're cooking. Now you got some good animal feed. This is an Elaine Ingham-like picture. I wanted to get a nematode in here. And here's some nematodes consuming something that they didn't want in the soil. So, is that a termite? I don't know. Some kind of drug. And fungi. This is in my backyard. This is turkey tail. And these aren't mycorrhizal fungi, but I like to show that picture. So. Christine Jones is coming. NOFA's bringing Christine Jones. I think NOFA's about the best organization in the world because they get all these people here. When she started talking about liquid carbon pathway, I was amazed. How did I not know this? I mean, because it's so intuitive. And Judy Schwartz, who's from Vermont, and she's a reporter, and she started reporting on this stuff, and she didn't know a lot about, soil and whatever when she started studying it. But her first chapter in this book talks about Peter Donovan, who's going to speak here, and riding around in a school bus measuring soil. In her second chapter, she talks about Christine Jones. And she doesn't get to Alan Savory till the third chapter, but by then Alan's got something to stand on. Because she's talking about something. Liquid carbon pathway is probably the most important thing that we ought to be researching. And Elaine Ingham's doing that. But how many of the agricultural colleges are spending time on this idea? I wanted to say yesterday when Elaine Ingham was talking about this, and she says that the organisms can be acres and acres and square miles in size, and there's so many cells in these networks. At what point do they become conscious? I wanted to ask that, but I thought, well, I'd be disrupting the files. And so does anybody know? How many cells have you got in your brain? And compare that to a 20 square mile size network like this. What is it doing down there? What if we ripped all of that out? Would it be different? This is absolutely critical to the future. This is the glomalin coating actually has an effect on this is infrared or ultraviolet. So this is a picture that was taken years ago at USDA. Here's some shiitakes that I grew that we never knew when they were going to come out, so we had to take pictures when they came out. But, these are all, some of these are 6, 8, 10 inches in diameter. Here's what you do if you have some hay. Sometimes you can take mycelium that you've grown on a petri dish and get it to grow that thick. That's my hand there for scale. But here's what are they?
Oysters.
Oyster mushrooms. That was the goal. Oyster mushrooms are incredibly easy to grow, very hard to preserve, so you got to eat them fast. They sure taste good. This woman lives in Vermont, or used to anyway. She, let's talk about, she's from New England, talking about New England, and she started out with beaver. So she comes back to beaver. And I think that's a great book. If you're trying to understand biodiversity, she gets into freshwater clams, which used to be every stream in the east. Prairie dogs. John Carroll is at University of New Hampshire. Pastures of Plenty is an idea about what could we do with grazing in New England. And the Agriculture Commissioner for New Hampshire has a quote in this book. It says, "The new math dictates grazing." We have all these rocks in our soil. Why are we trying to plow? And you can have small vegetable gardens and things like that, but the idea of turning back into a major producer of grain or something like that. So then he had this picture. This is a map of New England, of course. I know Vermont fairly well. All that green areas which are considered from their, weaning down, they're trying to figure areas that might be good for grazing in terms of financially. And they didn't include the Champlain Basin because they thought, well, you want to grow something else there. You might make more money doing something else. But that doesn't mean grazing can't be done here as part of your plan.
There's a lot of grazing up in the Champlain Islands.
Yeah, yeah. So it's just, but it's an idea of places where we never think that you could be agricultural.
What are the white ones?
What's what now?
What are the white ones supposed to be doing?
Well, this is more where I guess they thought that they'd be doing other agriculture.
No, it's unproductive areas mostly.
I thought so. That's where I live.
It's mostly the Worcester Plateau, all the way, all those granite acid soils. He just said no.
Yeah. Okay.
Great.
He's actually in some of the slopes, some of the places he puts are green are pretty steep too. So.
See if we can zoom in on Grand Isle. See Grand
It's
Isle?
pretty dark up there. That's where I work.
Grand Isle, up on the island. This is one of the most beautiful places in the world.
Absolutely.
Absolutely. Okay. So, but just an idea, if you never thought, imagine if your goal was to increase the amount of carbon, amount of soil in your area, you might consider grazing as a possibility. And could you put down 20 tons per acre? Yeah, probably. It might take a decade or two. Anybody know where this is? Where does this look like? Here we got tumble wheels and we got electric fence. And the animals see a human walking by, so they're thinking, oh, it's time to move the fence.
This looks like Eric Noel's farm.
That's who.
That's where you work?
That's where I work
Oh,
for
good.
Noel.
Actually, this is his old farm.
This is the. Okay, well, this is.
Maybe, I don't know.
Well, I got this from Abe Collins. So I don't know how they know each other, but it's
They were neighbors.
But it's right along Lake Champlain. Now, do you see any bare ground there? It's probably not a fair question because you're not looking straight down. But these animals, it's not hard to herd animals in a situation like that because they know every time that the human comes out, a fence moves, and they want to be first because there's pretty good herd size. There's Abe. He's demonstrating all the soil he's making there. But actually, the cows are making the soil. And there's what it's all about.
This might Abe the other day.
Yeah. Abe will be here tomorrow. And Abe says, well, maybe this is a little too green. There's maybe a little bit too much protein. If they're eating too far down on the grass, that might not be good. They want them to keep on the top. So he said, maybe I need to move them faster. So, everybody know what those are?
Red Devons.
Rhodocawas, what Ridge calls them. Yeah, this is Ridge Shin brought Rhodocawas up from New Zealand, crossed them with Devons here, and these are actually live in Massachusetts now. This was one of the great stories of the. Yeah, yeah. He tells that story. The guy that was raising the Rhodocawas in New Zealand was saying he wanted to get out of the cattle business. And so Ridge says, you can't let that strain die. That's the best animals there are. And the guy says, well, do you want them? And he said, okay. And so he hired two 747s, flew them to Los Angeles. I think it's summertime in New Zealand. He gets to Los Angeles, and they've got to stay in quarantine for 6 weeks. And it's hot and dry and dusty and whatever. And then he flies them to New England in February. So they had quite a trip. And some of those animals that did that flight are still living on the farm. This was, I don't know, and there he is. He's wearing his Alan Savory hat. I joked to him about that. And here's what do you see in there? What's that? Okay. What do you see in there? Beekeepers. This is Vanessa Roll and Eric Becker in Stratford, Vermont. Do you see any bees in that one? What are those flowers?
Knotweed.
Knotweed. You know what? Knotweed's an invasive species. You can make honey out of that stuff. This is the sweetest honey I ever tasted.
It has a distinct flavor.
And this is Isabel. She's having her 13th birthday, and there's the honey right there. So I just thought that I ought to bring some friends here. These are the goats that made the Boston paper a couple weeks ago. And look at what they eat. Poison ivy, buckthorn, Japanese knotweed, and Asiatic bittersweet. How many people want to have less of that on their land? How many people want to use Roundup to solve that problem? We have one here. You can also put on multiflora rose. You know, this would be fun because goats are fun, and like I have some more goats. So
they do eat other things too.
They'll eat actually species from around here. But there's the wildflower honey, they called it. But don't tell them it's Japanese knotweed is in there. So. But there's some goats that recently came to Arlington. This is Rufus and Will, and they're working on Jane's backyard. And now they knocked down the ladder there, and the chickens and the goats are trying to decide who's in charge. So I thought that was a good picture.
And so who's in charge?
What type of goat is that? What kind of goat is that?
Those are 14-week-old dwarf Nigerians.
Dwarf Nigerians. 14 weeks old. And they're already...
Making some serious progress.
Anybody know where that is? They're here, actually, the Larsons. This is Rich and Cynthia Larson. And they're horse people. And that's the daughter, Mercy, who's an incredible horse person at like 12. She's in college now. But they've got about 200 acres. They had an area out there that they bought that was about 50 acres. And they put the animals out there, they put the cattle out there, and they just bawled and complained and cried because the grass out there had no nutritional value at all. And they just got them right back out of there. And we talked for a while, and I said, well, Joe Maddox back in Texas would never put animals, he would never feed his animals hay in the barn. He put the hay where the worst land was because he'd want the nutrition to go there. And I hadn't got the sentence out of my mouth, and Rich was out saying, I can roll those bales out down the hill. And the next year he had grass that the animals really jumped on. So it's, put this hay where the worst places are, and you can have some really good grass in a pretty short time. And there's, Vermont's Vermont. Here's another place that's different than Vermont. The soils are a little different. This is, 6-inch deep concrete, asphalt. And this is the Somerville Climate Action Group. When they decided that they couldn't change policy or politicians, they decided to take matters into their own hands and learn about tools. And there's Vanessa and Emily pounding on things. And look how thick this stuff is. And they decided that there were people in Somerville's 80% impervious surface, rooftops, pavement, and they have flooding problems. And the town loved this idea. If everybody's got a backyard that wants to have a garden, the climate people will show up and help you get rid of that stuff. And so this is what the soil looked like. It hadn't seen organic matter in quite a while. And this is Rebecca Gerwitz, is the alderwoman of the town, of that part of the town, and Maureen's there, and they're putting salt marsh hay. So that winter, you had a carbon source on the top of that. And the next year they had, I'll show this picture. It looked a little different. You just kind of overdrew with wildflowers and whatever. The next year, it's become like an urban garden. There's like 4 or 5 families who get food out of this little space. And so now in Somerville, if you want to do something for the climate, you get a whole bunch of people over to your house and you tear out the asphalt. And maybe someday Somerville will only be like 75% impervious surfaces, Yeah, and the first time when they did this particular project, so that's what it looked like at first. Now look, we found out that there were never any depressed depavers. Do you see any depressed depavers there? This is fun. Taking responsibility can be fun. But, So imagine the carbon cycle, and then Peter Donovan, the crusty man that he is, always tells me things. This word sequestration. Don't you love that word? So, in Spanish it means kidnapping. What we need to do is slow down the carbon cycle, which means slow down the water cycle, which is what the beaver are trying to do. We don't need to amputate it or stop soil respiration. You can continue to breathe. If you're going to go out and depave, you can still breathe. You don't have to stop breathing in order to change the climate. All animals have to breathe. So Peter's he'll be here at 3 o'clock. And let's see what else we got. Oh, I'll show a picture. Here he's in Vermont. He's trying to get his phone to work, and we're climbing over mountains to see if his phone will work. And it never did work. You can kind of tell.
Hey Jim, you want to just tell us a little bit more about the 200 million beaver?
Oh, okay.
Yeah, 11:30 also.
Yeah. 200 million beaver.
Well, I read Alice Atwater's book and she told me to.
Oh, okay. New England used to be 10% ponds and wetlands due to beaver activity. Now think about how much carbon goes down in a situation like that. And I think if we want to restore the West, like West Texas, if I were in West Texas right now and I had any land at all, I'd hire prairie dogs and beaver to show up. And I know that things would change. And I'd get cattle too. And I'd encourage antelope to come if they could get there. You know. But yeah, I think that's. And I wanted to show I just wanted to show. We're right at 11:30 right now. And if people have to go, that's great. But if, I was going to show a movie that it's 6 minutes about water infiltration. And it's a little test you can do that anybody can do. And if you can't see it this time, maybe Peter might show it too. But is that a little bit about what you wanted me to say? Okay.
Whatever you say is what I wanted you to say.
So this is from South Dakota. And I really like this enough that I decided I'd go out and try to do this. So that's...
Lacking structure we had down further, or the granular structure. That is due to some compaction going on. That is mostly due to...
We have to start at the beginning here, sorry.
The management of South Dakota's grazing lands is paramount to the healthy functioning of our soil and water resources. Sound management practices not only lead to economic but ecological sustainability, while improper management reduces the resource's capacity to function and can lead to the invasion of non-native species. Recently, conservationists have been studying the effects that management has on soil properties such as infiltration, and the results have been dramatic.
I'm Stan Wolf. I'm the State Range Management Specialist here in South Dakota with the USDA Natural Resources Conservation Service. We've come out here today to look at a difference between these different sites of grassland. On the other side of the fence, we have one of the common grazing systems that you see out here, basically what we call a continuous season-long grazing. What you have is a real uniform plant community, blue grama, Kentucky bluegrass, not a whole lot of diversity. And as you can see on the west side of the fence here, we have a very high diverse plant community, very productive. We've got big blue stem, western wheatgrass, and a lot of forbs coming in as well. So the diversity on the west side of the fence is much higher, as well as the productivity and the vigor, the health and vigor of the plants are much higher as well.
Infiltration rates reflect a combination of factors on the surface of the soil as well as underneath the surface, such as litter in contact with the soil, biological and chemical soil crust, structure, porosity, bulk density, and soil aggregate stability. So we use the single ring infiltrometer to measure infiltration rates on different types of management to give us an overall picture of soil health on grasslands. Let's take a look at these results on well-managed, rotationally grazed rangeland.
10.1 seconds. We often see good granular structure on grassland soil across the state. The better the management, the deeper that is, and the better the infiltration and the lower the runoff will be.
Well-managed grasslands not only benefit the plant and soil resources, but also pay dividends in the management of livestock. Well-managed grasslands have higher diversity, and this leads to higher overall palatability and a higher plane of nutrition for a longer period during the growing season. In addition, well-managed grasslands have a positive effect on production.
And some have said as much as 150 to 200 pounds per acre of production will be lost with every inch of water that runs off the soil. So this infiltration matters quite a bit in terms of how productive the rangeland will be, and it ties into the bottom line, the economics of an operation as well. So we've run through, and it took 7 minutes and 3 seconds to get that inch of water into the soil.
Overgrazing, either by overstocking land with too many animals or allowing the animals to graze for too long of a period, which leads to repeated grazing of individual plants, leads to negative changes in the plant community. This affects not only the plant health and production, but also results in changes to the soils.
You can just see that nice granular structure that we had all the way through the profile across the fence is just not there. Another thing you can kind of see is right in here is this platy, these layers of soil that are going more sideways than up and down. There's a good example right there. The soil breaks apart in the horizontal layers as opposed to the blocky structure we had down further, or the granular structure. That is due to some compaction going on. That is mostly due to a long history of heavy livestock grazing that has caused that compaction below the surface there. Every minute that goes by is another inch of rain that's going to run off the land and not come down into the soil profile and grow grass.
Now let's take a look at land that was converted to cropland just 9 months before these tests were run. The existing grass was treated with a herbicide, and the corn was drilled into the grass residue without any tillage being performed.
Any guesses?
So we've let this run its course, and our water has finally infiltrated. Looks like we ended up with 31 minutes and 13 seconds.
1 year.
For it to infiltrate on this recently converted cropland.
We've seen the effects that different types of management can have on infiltration, and we've also looked at some of the soil properties on well-managed grassland and grassland managed with continuous season-long grazing. But you can't get a complete picture of the effect of management on soil health until you look at the soils side by side underneath the different types of management. Well-managed grasslands have deeper rooting of the plants, better structure, and the darker soils extend further down into the profile. These are characteristics we can see, and by measuring infiltration, we can also quantify the impacts of healthy soils.
Studies like these show that infiltration is significantly impacted by the management practices being implemented on the land. Increased infiltration resulting from better management means the water that falls on an operation will benefit that operation. Changes in management don't have to be drastic to have a positive influence on infiltration and ultimately improve your natural resources and your bottom line. I encourage you to learn ways to improve your soil health, increasing infiltration, being selfish about the rainfall that falls on your farm or ranch.
So that was 6-inch irrigation pipe. And then they just used a piece of saran wrap.
The management of South Dakota's grazing lands is paramount to the healthy...
6-inch irrigation pipe. Use some saran wrap. Set it in there so it won't start leaking too fast. And then you time it. And
Is that like a cup of water?
yeah.
Is there a sensor at the bottom?
No, you're gonna have to eyeball that. But I think that's a good little test. You know, you've got to find an area where there isn't obvious cracks or whatever. You know, but you know, the idea that if you have blue stem grass or have deep rooted grasses, the water can go down pretty fast. But if you're doing continuous grazing and your species mix changes, it can be a lot longer. And it might look fine, but and then of course I've seen it go the other way too. I saw this ranch or farm in Pennsylvania in a suburban area that had been growing corn for years, and I couldn't pound my trowel in more than a half an inch. You were there that day. I couldn't get my trowel to go in more than ½ an inch. I didn't have anything else to work with. And then, but in the area where they've been grazing for 4 months, the trowel would go in like 3 inches. And I thought that was, wow. They thought that was, they liked that. And it turned out to be the only area where they didn't have any nitrogen in the there was a pumping station not far from that place, and there was no nitrogen at the pumping station. That was, nitrates in the water. And the year before, when they had, they had all that animal poop, but they didn't have nitrogen fertilizer out there. So I was thinking, well, if you can go down 2 inches in the first year, that's not too bad. But maybe you can do even better than that if you get your grazing plan. They were running 37 animals, 37 cows on 1/10 of an acre, move them every day. In what Greg Judy called strip grazing. So 37 animals on 1/10 of an acre, move them every day. So that's 37,000 pounds, 1/10 of an acre. It's 370,000 pounds per acre density. But yeah. So we can do stuff like that in New England. Sure. So I got a phone call. Thank you for coming. I've got books up here about a lot of this stuff. And yeah, if you get a chance to see...
Conference announcement.
We already announced the conference, I think.
No, you didn't.
We have a big conference that Adam's going to tell us about.
Restore ecosystems to reverse global warming. We've been talking about it all morning, how you do it. We can do it. We have to bring this into focus in the climate conversation so that we develop a global action plan for making it happen. Lots of pieces are coming together. We have to move that along. So please come to our conference, pick up a flyer, November 21st through 23rd at Tufts University.
Oh, thank you.
Here you go.
I got it.
You got it. Plan you can sign up online.
This is the Cal site.
Where we have
Autumn and I have to go back.